Today we're going to take a look at our final lesson in Chapter 6 on polynomials. This is Lesson 6.6 on the fundamental theorem of algebra. And our goal today is to use the fundamental theorem of algebra in order to solve polynomial equations with complex roots. So let's take a look at what the fundamental theorem of algebra is. It says that if we have some function p of x that's a polynomial of a degree greater than 1, so it's not a linear equation, and it has complex coefficients, then this p of x, this function equal to 0, has at least one complex root. The corollary says that including imaginary roots and multiple roots, an n-degree polynomial, I can't write in there, so go ahead and write n-degree polynomial has exactly n roots, and the related polynomial function has exactly n zeros. So the first part talks about an equation, and it talks about the roots. The second one is just a function, so it's not equal to 0, but it has exactly n zeros. Let's look at an example. All right, so we have this polynomial x to the fourth minus 3x cubed plus 4x plus 1 equals 0. And we want to find the number of complex roots, the number of real roots, and the possible number of rational roots. So by that corollary of the fundamental theorem of algebra that we just looked at, this is to the fourth power. So it has 4 complex roots. Go ahead and write 4 complex roots in there. By the imaginary root theorem, which we didn't go over because it was in 6.5, this equation, it either has no imaginary roots, it has 2 imaginary roots, or it has 4 imaginary roots. Those imaginary roots, those are the things like 6 plus or minus the square root of -4. So they come in pairs because of that plus or minus, okay? So this is 2 imaginary roots or 4 imaginary roots, which is 2 conjugate pairs. So the equation either has 4 real roots, 2 real roots, or 0 real roots. And the rational root theorem says that the possible rational roots, so far we have complex roots, we have imaginary roots, and now we have rational roots. Rational roots of the equation, for this particular equation, are going to be +1 or -1. And we'll take a look at why that is and how you can figure that out. I'm actually going to do the quick checks with you in this particular lesson. So let's go ahead and move to the quick checks. To find the number of complex roots, the possible number of real roots, and the possible rational roots. Because this is a 4th degree, the complex roots, so remember I said that they come in pairs, so there's either going to be 0 complex roots, there's going to be 2 complex roots, or there's going to be 4. And there can be up to 4 because this n, the biggest exponent, is 4. The number of real roots is based on complex. So we can only ever have 4 roots total. So if there are 0 complex roots, that must mean there are 4 real roots. If there are 2 complex roots, there are 2 real roots. And if there are 4 complex roots, there are 0 real roots. And let's figure out what the possible rational roots are. For that, we need this coefficient here, and we need this coefficient here. And we're going to look at what the possible multiples or the things that we could use to multiply to get those two numbers. So this number right here, we're going to call Q. Okay? And in this case, Q is equal to 1. So what are the numbers that we could use to get to Q? Well, just 1. 1 times 1 is going to get us 1. P, on the other hand, this one right here, and it's 3. So what are the numbers that we could use to get to 3? Well, 1 and 3, because 1 times 3 is 3. So our possible rational roots are going to be using those P and Q. And it's always going to be P divided by Q. And we need positive and negative versions of it. So positive and negative versions of 1 divided by 1 and 3 divided by 1. Or positive or negative 1 and positive or negative 3. So we found the number of complex roots, 0, 2, or 4, the possible number of real roots, 4, 2, or 0, and the possible rational roots. It's either plus or minus 1 or plus or minus 3. All right, let's go ahead and take a look at our last example for 6-6. This time, not only are we going to find the number of complex zeros, but we're going to find all the zeros. It says by the corollary of the fundamental theorem of algebra, there are at least one complex zero. Okay, so we're going to use synthetic division to find the rational zeros. But first we need to figure out what the possible rational zeros are. So we once again need these two numbers. So P is this constant, which is 3, and Q is 1. Okay, it's the coefficient in front of the biggest x value. And so our possible rational roots are plus or minus P divided by Q. Well, what can make up P? 1 and 3. And for Q, it's just 1. So P divided by Q is going to be 1 over 1 and 3 over 1. Or plus or minus 1 and 3. Okay? So we need to try synthetic division to see if any of these are rational zeros. So let's do that. Let's try the first one. Let's try this positive 1. So we're going to use x plus 1. And in synthetic division, remember we need to change this positive to a negative. So we have negative 1. And, oh, look at this. We're missing some terms in here. We've got 5, 4, no 3, no 2, 1, and 0. So we're going to have to put in a couple placeholders. The first coefficient is 1. The second is 3. Then we're missing a term, so we need to put a 0 here. That would be the exponent of 3. We are also missing an exponent of 2, so we need to put a 0. Then we need a negative 1. And finally, negative 3. So let's use, oops, sorry about that. Let's use synthetic division. So we bring down the 1. Negative 1 times 1 is negative 1. 3 minus 1 is 2. Negative 1 plus 2, or times 2, is negative 2. 0 plus negative 2 is negative 2. Negative 1 times negative 2 is 2. 0 plus 2 is 2. Negative 1 times 2 is negative 2. Negative 1 plus negative 2 is negative 3. And finally, negative 1 times negative 3 is 3. Negative 3 plus 3 is 0. So since this remainder is 0, that means this really is a factor of this polynomial. So we're left now with x to the fourth power plus 2x cubed minus 2x squared plus 2x minus 3, and this whole thing would be multiplied by that, x plus 1. So we already found one rational root. All right, let's keep going. So the next one we want to try is negative 1, x minus 1. For synthetic division, we need to change this to a positive 1. And since we already know that this goes into the polynomial, we're left with this. So we can use this for our synthetic division. So the coefficients we need are 1, 2, negative 2, positive 2, and finally negative 3. So let's do this again. First we bring down the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. 2 plus 1 is 3. And finally, 1 times 3 is 3. And negative 3 plus 3 is 0. So once again, we found another root. That was 1. That was 1. So what are we left with? We're left with x now, instead of to the fourth power, this is to the third power, plus 3x squared plus x plus 3. And we know that this is multiplied by x minus 1. But it's also still multiplied by x plus 1. All right, let's keep going because this isn't completely factored yet, and we have a couple more options. We've got this positive 3 and negative 3. So let's try positive 3. So x plus 3. We need to change the sign for synthetic division to negative 3. And our new coefficients are 1, 3, 1, and 3. Synthetic division, first bring down the 1. Negative 1 times 3 is negative 3. 3 minus 3 is 0. Negative 3 times 0 is 0. 1 plus 0 is 1. Negative 3 times 1 is negative 3. And finally, 3 minus 3 is 0. Well, what do you know? Another factor, because that remainder was 0. So now we're left with, we had an x cubed, now we're left with x squared. There's no x term because this is 0x and plus 1. But let's not forget we have two factors that we already found. So x minus 1 and x plus 1, and our newest one, x plus 3. All right, so let's see what we're left with. We're left with this quadratic, but this is not a difference of squares, so we're not going to be able to factor this any further. And the original question asked us to find all the zeros, so that means that we need to set each one of these equal to 0. So first, x plus 1, is 0. So if we subtract 1 from both sides, we find out that x is -1. That's one of our zeros. That's one of the numbers that makes this expression equal to 0. The second one, let's do x minus 1 equals 0. Well, in that case, we have to add 1 to both sides. So that means x is 1. I'm going to skip to this one. We're going to come back to this one. So x plus 3 is 0. That means if I subtract 3 from both sides, I get x is -3. And finally, let's deal with this one. X squared plus 1 is 0. If I subtract 1 on both sides, I get x squared is -1. How do I get rid of this square? Well, I take the square root. Do that to both sides, except now this thing has to be positive or negative. So x is positive or negative the square root of -1. Except we talked last semester about how we represent in math the square root of -1. We call that I. So x is either positive or negative I. So our solutions are, let's come back up here and look, -1, 1, and -3 were our real zeros. So -1, 1, and -3. And our two complex zeros are these, the plus or minus I. So x is either I or -I. Let's take a look at this quick check. Okay, I'm going to start this quick check for you, but I'm going to leave you to actually finish it. So I'm going to help you find what the possible rational roots would be, and then you'll have to check each of them to figure out what the actual answer is going to be. So let's take a look at what the possible rational roots could be. Once again, we need this coefficient and this constant. So our P is 8 and Q is 1. So what are the numbers, the factors in 8? Well, 1, 2, 4, and 8. So our possible rational roots are plus or minus 1 divided by 1, which is 1, 2 divided by 1, which is 2, 4 divided by 1, which is 4, and 8 divided by 1, which is 8. So that's quite a few options that we need to check. So let's go ahead and start. So if we try x plus 1, let's use synthetic division. First, we need to change this positive to a negative, and then bring down each of the coefficients. So the first one is 1, -2, 4, and -8. So let's try this. Bring down the 1. -1 times 1 is -1. -2 plus 1 is -3. -1 times -3 is 3. 4 plus 3 is 7. -1 times 7 is -7. -15. Well, our remainder's not 0, so that means this does not work. Let's try the next one, -1, x minus 1. We change this negative to a positive 1. Bring down each of the coefficients. 1, -2, 4, and negative 8. Bring down the 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. 4 plus negative 1 is 3. 1 times 3 is 3, and negative 5. So once again, this wasn't 0, so this is not a factor of that polynomial. Let's try 2. So x plus 2. Change this positive 2 to a negative 2. Let's try the same coefficients. So I'm going to let you continue from here. You're just going to repeat this pattern until you figure out what the factors of this polynomial are. Good luck.